In the previous installment, we assembled our code into a binary file. Next, we would like to try to run our binary file. Now, when working with lower level programming, it is possible to write some value to the wrong place in memory and mess up your computer pretty good. So to prevent that, we will be running a virtual computer using software and essentially fake out our program into thinking it's running on a real computer. Now, there are a number of different emulators out there. We will be using Qemu for this demonstration. Then we will quickly cover how to make a simple bootloader, hopefully without making too big a production out of it. So let me start by going to our assembly folder, right click, assembly, there we go. And I want this path. I'm going to grab that, copy that, get out of here. Let me go to our command prompt and change directories there. All right, I can go ahead and dir and see there is our binary file that we would like to assemble using Qemu. Now let me real quick just grab that name. I'm going to go here down to the C disk, program files, Qemu, and if I go all the way down here, there are all these different flavors of emulators that you can run. You can emulate an ARM processor, an old 386 computer. You can emulate a MIPS, PowerPC, RISC, Spark, all kinds of things. Awesome. You could go in there and play around with those all you want. But right now the one we're interested in is right here. I'm just going to click once, wait a second, and then click again so it highlights that, and then copy that. Let me just now go up to my documents, assembly, go to my snippets, and paste that right in there. Save that for later reference. Okay, so it's still in memory, so we can run it. I'm just going to right click here, there, and we want to assemble our btab binary file. Okay, so Qemu will give you some errors. I can't do anything about that. I'm going to Control-Alt-F here. And this is just like if you took a computer and turned it on with nothing on it. No operating system, no software, nothing. Your computer does have some capabilities built into the hardware to print text to the screen and do various things. Check for various devices. Here it made several attempts to find something to boot from. First looked in the usual location, couldn't find anything there. Let's see if there's a floppy. Nope. CD. Nope. It even attempted to boot off of a network. Like if you're an administrator, you can IT administrator, you can have a single operating system that you make updates to, and then all of the computers on the network boot off of that, so it makes it simpler to make changes over an entire network. The computers themselves have no operating system on them. They go find it off of the network and boot off of that and run it that way. But I digress. That's another topic. I can Alt F4 to get out of there and return back to the command prompt. Now, let's see. So we tried to run our binary file. It didn't run. Okay, great. What's the point of that? Let's go look at it. There is our DB0 in Notepad++. Now, I seem to be fascinated with zeros. Yeah, I could write more zeros here. DB0, DB0 ad infinitum, but you don't really need to do it that way. There's also built into the assembler, the NASM assembler, is a way to do that a number of times. So I could just specify I want it to DB0 512 times. And let me just save that, and then I will go NASM it. Oh, I haven't done that yet, so let's do it this way. We will type S for shortcuts, enter, and I want this bit out of there. I can just copy that and then paste it there, and it overwrites our binary file with the new code. So if I want to look at it, we're set up B tab with a binary hex editor. Great, there it all is. Now, great, now I've written 512 zeros. What is this pointless exercise all about? Well, this goes way back to the early days of computing, when computers only had this much memory, 512 total bytes of memory. Of course, it's not like this is a 0 and this is a 1 and that's a 1 and that's a 0. Each of these, of course, is 8 bits, as you know. But that's the total amount of memory that was available on early computers. Later, of course, they upgraded that. Today, you know, you can add RAM and have gigabytes of extra memory on your computer if you want. Back then, you were limited to this much. So when they made the next generation of computers, everybody's like, well, what about all the programs we wrote on your old computer? Now they won't run. You know, we spent all this time banging our heads against the walls, and now they're obsolete. And so they made it backwards compatible. In a nutshell, today, every computer, well, not every, but every x86 computer will look in this boot sector to see if there's some code that it can boot off of, this 512 bytes of memory boot sector. So that's what we're going to start by writing into. Now, of course, we've just written a bunch of zeros. That's not very useful. Also, even if we have some code in there, it won't run. We need a special key to unlock the x86 hardware. Now, I'm not going to do this the old-fashioned way. I think this is also interesting. If I go write it in binary, db, that would be 01010101 in binary, followed by 10101010. There. That is the magic number, as it's often referred to in the programming community, that actually unlocks your hardware. Your computer would not run without these two essential bytes of code. Okay, so let's go over here real quick. If I up arrow a couple times, there's NASM. And now we want to try and launch that in Qemu in our emulator. Let me copy that and just paste Control V. Oops, wait, did I actually copy? Highlight, Control C, Control V. There, okay. And let's run our B tab binary file. And no, it's not running. It's not finding a bootable device. Okay, and the reason for that, let's have a look at our binary file, shall we? Now it's binary. There we go. The problem is, whoops. Well, for one thing, our magic number is not in there. Why is that? Did I not save? I didn't save. Okay. Well, that would do it. But no, hang on. It still won't run in Qemu. Okay, let me just Alt F4 out of that window. If we look at it, B tab, here's the problem. It's not running because these 2 bytes of magic number need, the key to unlock it needs to be in the right lock. So just, I mean, anybody could have hacked into a system just by writing a bunch of random numbers until the computer did something. But it makes it a little harder, I suppose, if these numbers need to be in a special location. In this case, they need to be in these last 2 bytes of our limited 512 bytes of memory. So I guess an easy way to do that would just be delete 2 zeros there, and then I can save it right here from our hex editor, and then get out of there. And if I'm not mistaken, I should just be able to run Qemu from here. And now, yes, it boots. There's nothing in there. But as you can see, it did not go through the usual rigmarole of checking for one hard drive, checking for a floppy and all that. It found it right away, right where it was supposed to be, in the 512 byte boot sector, you see. So, and of course it didn't write anything. It's just an empty blinking cursor because there's nothing in there. There's a bunch of zeros. But now we have our blank page into which we can write our code. So there you go. That is your bootloader. Let me just close this window. Oh, another thing I should probably mention. Let's say I'm doing some changes over here to my code, and then I want to go over now and assemble it. And I go over here and whoop, where's my command line? It disappeared. Oh, I can't run a program. Why not? Well, Qemu is still in the background, which you can't see because I've conveniently covered it up with this window, but here it is. You can find it here. Still running in the background, and I can just click on that and get out of there, and there, it returns us back to our command prompt, you see. So sometimes you can't even run various applications because this is running in the background. So if you're, it's like, why is my system locked up? You know, there now you know. So here, let's see, we have our magic numbers. We have adjusted it manually and it worked, and then we fixed it and now it works again. Great. Let's say now I want to write some code in here, and I'm just going to kind of copy and paste some code real quick, you know, to save time. It's almost not even assembly code. I'm just manually poking some numbers into some registers here. Okay, but good enough. And let me save that and then go over here now and NASM it and have a look at it, and it's not finding it. Why? If anybody was paying attention, they probably know why. I'm doing this on purpose, of course, but the reason, let's look at our binary, is here we added some code up here, and look, now our magic number is no longer in the proper spot, right? So here, let's, how many bytes of memory code did we add? 1, 2, 3, 4, 5, 6 bytes of code. Okay, so let me just go back to our application here and fix this. So it's 512. This should actually be we made a manual change here, where, remember, we subtracted 2 zeros in the manually in our hex editor. Well, we didn't do the same here in our application. For one thing, this should be 0 here, but even so, here, let me just go ahead and save it. We know that we've overflowed. There's some extra code up here, you know. So let's see, if it was 512 and we had, what was it, 6 bytes of code in there, that would be what, 506. There we go. Let's save that, try to run it, and NASM it, Qemu it, and no, it's still not finding it. Why is that? Let's have a look at our, why am I typing? I can just go B tab there. Oh, missed it by that much. All right. Of course, you know, so I could go back in there and subtract 2 more from that. But yeah, so let's do that. I'm going to save it out. Let's go back to NASM. There, Qemu, and there. There's our happy computer. We have some running code. Wonderful. Okay, so that works. Now let's say, okay, I'm gonna like to maybe add some more code, do some more editing. Got it working, great. There, maybe add a little bit more code. Let me save that. Remember, have to close this first. Okay, and let's have a look at it, and it's not running. Oh, right. We know why. Alt F4 out of there. Here, let's look at it just to be explicit. B tab. We went over. Again, we added 4 more bytes. of code, and now we're 4 bytes over the magic number being in the right place. Well, this can be tedious. If every time I add a little bit of code, I have to go back and adjust this number, couldn't there just be like a way where you can find how many bytes have been used up to this point? Well, yes, there is actually. So just to do it the hard way to prove a learning curve here going. There is a way, and if I inside the parentheses type dollar minus dollar dollar, this bit of code here will return the value of how many bytes have been used in the program so far. So fortunately for us, this should be 510, because remember it's 512 bytes total program minus the last two, right? So we want it to be 510. Let me cut that out of there. Minus this, however many bytes have been used up here, which is minus this. And this is easy enough to remember. It's for every dollar you make, you get $2 in the hole. You know, dollar minus dollar dollar. There you go. So now that should be easy enough for you to memorize from now on. So let's save that. Go over here to NASM, run it, and there. Now we have a very happy computer. It just loves the code that we sent over there, right? Okay. So let's. I just want to play around a little bit more. There's your bootloader. It's working. Everybody's happy. The computer's happy. Yeah. Next, here I've written some binary numbers in here. You know, just to be cute, I guess. Let's look at that real quick in our hex editor. Here it is expressed in hexadecimal. This is the value I put in, 10101010. Yeah, 8, which of course is the explicit value, 85. You see, so here it's expressed in hexadecimal, of course, you know, but I could actually put the explicit value 85 in there. Let me just close out of there. Let's see. Yeah, here I'm expressing it in binary, but I could just say 85, you know. And what was the other one? Oops, I already closed it, but let me just run that, save it, have a look. NASM it, Qemu it, and we have a happy computer. You see, it's all just numbers to the computer. Let me look at it. You know, this is what the computer sees. It's a bunch of switches. It sees this value is on, this one's off, this one's on, this one's on off switches, right? So ultimately, no matter what value we use, this is for our convenience right here. This is in decimal, so we can read it. This value over here, that's for the convenience of nerds who, you know, who can't speak in plain English that the rest of the world can understand. But so it's there in a bunch of different formats. Observe here. Here it says 55 in hexadecimal. Also, the character U, right? U, huh? Okay, let's try that. Here, instead of the absolute value 55, what if I just said U? Save that. NASM it, look at it, and what do you know? Love you. See that? What was the other one? Let's see. Let's look at it from here. The other one was this odd character A. Now, there used to be a way to write that directly from your keyboard, but they kind of changed that in Windows 10. I guess to get to that, now you have to go to character map here, you know, and then there's all these extended characters, and there it is right there. Your feminine ordinal indicator. Ooh, yeah. So you could just as easily put that in there as well. Now, let me just set this back to 55 in hexadecimal. And the other one, of course, was AA in hexadecimal. And what happened? The colors are different here. The reason for that is, fortunately, Notepad recognizes assembly, and it's telling us this is recognized as a numerical value, but if anything begins with a character, your assembler is going to assume that it is a variable name, I believe. So in order to tell it that this is a hex value, a number, you have to put a 0 in front of that. Okay, so let's just go ahead and run that. I close my window, so I need to go get my path again. Copy that path. Close that window. Alt F4 to close the active window. Go back to my command prompt. CD paste. Okay. And compile and run this. Let me go type my shortcuts. There. I want to compile this. Let me just go here. Control C, Control V, down there, and wrote it and executed it because I had copied the return as well. So now the binary is overwritten. Let's go ahead and have a look at it. Qemu, btab, binary, and run it, and everything is just fine. Computer loves that too. It's all just numbers to the computer, right? Let's reiterate another lesson that we learned a little earlier here. Here I've expressed 2 data bytes, 55, it's not 55, it's 85, 55 hexadecimal, or AA hexadecimal. We could also write a data word in there, which and combine both of these into a single numerical value. Let's do it this way. Go OX, which will tell it that it's hexadecimal. A 55, like that. See, so one way I could either, if I put the H there, tell it it's hexadecimal, or I could also put OX in front of there. It's actually something more like that, but it's ambiguous. You just say OX, and whatever follows is hexadecimal. Then I could get rid of this, save that, get out of this happy window here. There's no mistakes, just happy computers. And run it. If I up arrow till I find NASM, down arrow one time and it finds Qemu, there is, our computer is still quite happy with the code that we're sending there. It's all just numbers. Observe though, which I probably could have pointed out when I was writing it, Notepad, even though I just saved, I can undo and go back, because it's made for programmers. You're going to need to save your file to go run it, right? But then maybe it didn't run. You want to go back. Notepad has quite a few levels of undo, and you can go way back in your code, whether you have saved it once or twice or whatever. It keeps track of all that. Very handy if you're a programmer. But what I wanted to talk about here, DB55, DBAA. But remember, it's bass-backwards byte order, right? Because it's a little endian x86 processor, right? So when we send a word, instead of 55AA, it's AA55, right? Bass-backwards. There you go. Let's, I want to do something else here. We have now a working bootloader that works with any amount of code in there. That's really nice. Just to play around. Let me copy all of this. Copy that. And then I'm just going to delete this bit, save my test ASM, and then paste it again, delete that bit, and save this as. Now, it's a bootloader, but I'm already using B for my binary, so I'm going to keep that sacred, and we'll call this, how about magic number. .asm, good enough. There, the magic number. So, just to look there in my assembly folder. Okay, we got, there's our code now, which is stripped of the bootloader, but there's our bootloader, right? So we should know by now that we can go just copy our T tab plus M tab into a new file. I'll just call it combined.asm. All right, and enter. One file copied. Let's have a look at C tab. There. All of our code has been concatenated. The bit of code in our test file. Let me go ahead and open it up. There's our code. So now, I mean, that's one way of working. I might not even do that for the duration of this tutorial, but it's there if you want to do it that way. It's kind of nice. You got your code free and clear, which you can do other things too. I mean, I could use it in other ways. I could call it from another location, use it as a function, etc. This is other things down the road. But there, that code combined with this code, and it writes this thing in here which is inconsequential. It still runs. It's still recognized by the compiler and by the assembler and by Qemu and everything else. If this weird symbol bothers you, you can just delete it, really, and hit save. But it doesn't matter. And if there's a way to not assemble it and have that little, feel free to leave that in the comments. Maybe I'm not going to go back and fix the whole tutorial just for that, but if it's in the comments, okay. One more thing I want to do here. Let me go write my TYPE, my shortcuts. There, I got my Qemu shortcut, but and I don't know. You'll memorize all of this eventually, but you don't have to. In this case, Qemu, I'm going to do one more thing. Let me just, I'll leave this open and go open my file explorer and go to my Qemu folder, local disk, program folders, Qemu, right? Oh, actually, let me tell you what I want to do first. I want to make a copy of this. I mean, I could change the name of this just to Qemu, shorten it, but maybe I want to keep this for later use or something. And well, it's only 14K, so I'll just make another copy of this and called Qemu, and then it'll be easier to call. Unfortunately, I can't do that from the normal command prompt. It will complain. You have to be in administrator mode. So you type CMD down here in the search bar. Okay. There's your command prompt. Go to run as administrator. Okay, and it says, do you want to do this, yes or no, which you probably didn't see because it's not recorded in the OBS. But I clicked OK, and then, okay, so now I need to be here. Okay, so let me copy the path and change directories here. I'm in the Qemu folder. Let me just okay. Now, where's our application? Right here. This is the application. I'm going to copy that name, Control C, and then we're going to use the copy command. Copy, Control V, and change that to just Qemu.exe. Whoops, do not. Qemu.exe. Enter. No complaints because I am in administrator mode. All is swell. So now, this is really nice. Let me get out of administrator and go back to our normal command prompt. to my assembly folder, copy that path, and change the directory to the path. Okay. Okay. There's our binary. I'd like to run it. So now I can just type Qemu B tab, and it runs. There's our happy computer. Nice. Why didn't we do that in the first place? Well, I'm giving you different options, showing you different ways to do it. You can choose to work however you want, you know. But wow, now we've really set up a streamlined system where we can edit, assemble, and execute our code with just a few simple keystrokes, you know. So that can really make you fly in your development, all right? So there you go. Now I guess we're all set up, ready to rock and roll. In future episodes, we can focus more on writing some assembly code.